Hi, this is Mr. Mac, and this is the concept video on solving linear equations. First of all, let's define what an equation is. An equation is actually one mathematical expression linked to another mathematical expression by an equal sign. Now, an example, for example, might be 3x plus 2 equals 20. Now, sometimes we refer to this equation as an open sentence. Because what it really says is that 3 times the number plus 2 is equal to 20. Now, 3 times the number plus 2 is equal to 20 might be true, and it might be false. See, now if x were 6, 3 times 6 plus 2 would be equal to 20. But if x were 5, 3 times 5 plus 2 wouldn't be equal to 20. So an open sentence is one that can be true or false. Now, the number or numbers that actually make an open sentence true are called the solutions. Sometimes they're referred to as roots as well. So if you hear somebody talking about roots, they're actually saying these are answers to some kind of an equation. A lot of times roots is the term used for polynomial equations of higher degree than 1, but we'll talk about that later. Now, since we are actually using the equal sign now, it makes sense to talk about what properties the equal sign, or what are the properties of equality. Well, now, the first property of equality is a property that's called the reflexive property. And this one's really pretty easy to handle. The reflexive, that's a V there. The reflexive property basically states that any number, A, is equal to itself. So anytime you have a number or an expression, you can set it equal to itself if you wish. The second property of equality is called the symmetric property of equality. And it's a conditional statement. It says if you have A and you know it's equal to B, then it's also perfectly acceptable to say that B has to be equal to A. Now, if you look at this carefully, this looks a little bit like the commutative property, but it isn't the commutative property because now A and B are moving around an equal sign rather than a plus sign or a multiplication sign. So if A is equal to B, then B is equal to A is the symmetric property of equality. The third property of equality is the property called the transitive property. Now, the transitive property kind of gives you a chain of linked equals. In other words, if A is equal to B and B is equal to C, then by the transitive property, A has to be equal to C. That's the transitive property. Sometimes, instead of transitive, we'll just say substitution. But substitution is a little bit stronger than the transitive property. Maybe we should mention substitution in passing at this particular point. The substitution principle says if A is equal to B, then B may be replaced by A anywhere B appears. And it's pretty easy to get the transitive property out of that, but as you can see, the substitution principle is a little bit stronger. Now, the next property of equality that we want to talk about is oftentimes abbreviated APE. Now, this stands for the addition property of equality. And it basically says if you have an equation, if you have an equation, in other words, if you have A is equal to B, then A plus C will be equal to B plus C. Now, the way I thought of this when I was younger was that if you had an equation, it was okay to add the same thing to both sides of an equation. If you'll see here, the equation A equals B right here, what we've done is we've added C to the A and we've added C to the B to get A plus C is equal to B plus C. That's the addition property of equality. And that's kind of an important one. We use that a lot in solving equations. The next property of equality that we need to talk about is the multiplicative property of equality, which basically says if A is equal to B, in other words, if you have an equation, then A times C is going to be equal to B times C. Another way of looking at this is we're multiplying both sides of an equation by the same thing. So APE and MPE basically say to you, you may add or multiply both sides of an equation by the same thing. Now, since subtraction is just adding the inverse, if we added right up here, if we added the opposite of C to both sides of A is equal to B, we'd get A minus C is equal to B minus C. So the addition property of equality will really let us also subtract the same thing from both sides of an equation. And since division is just multiplying by the multiplicative reciprocal, if we multiplied both sides of A equal B down here by 1 over C, we'd get A over C is equal to B over C. So it's easy to see that you could divide both sides of an equation by the same thing. Of course, you can't divide both sides by 0 because if C is 0, then 1 over C or 1 over 0 doesn't exist. So you can divide each side of an equation by any number except, of course, 0. Now, using the properties of equality, we want to talk about methods of identifying solutions. Now, if you have a linear equation, identifying a solution or solving an equation simply refers to identifying all the numbers that make the equation true if we go back to 3x plus 2 is equal to 20 as our equation, we would want to be able to identify all the numbers for x that would make that equation true. Now, 3 times 6 is 18. 18 plus 2 is 20. So 6 would actually be a solution to this equation. Now, the question does come up, is that the only solution? Well, it turns out in this case that it is. But now, how would we actually proceed? What is the mechanism or the method that we would use to solve a linear equation? Well, let's just take a look at, or let's just list a couple of things that you should probably do in order to solve a linear equation. Now, the first thing you should do is you should simplify both sides of the equation. If your expressions are complicated, they contain perhaps parentheses and multiple terms that contain the variable and so forth, the first thing that you would do is you would simplify each side of the equation if it's not already simple. Now the second thing you're going to do is you're going to consolidate the variable. Now what this means is if you have, after simplifying, if you have the variable, a variable term on the left-hand side of the equation and a variable term on the right-hand side of the equation, you would want to move through the addition property of equality the terms that contain the variable all to the same side of the equation, and then simplify them, combine those like terms into one single term that contains the variable. That would be consolidating the variable. Here's an example. If you had 5x plus 2 equals 2x plus 20. See, notice both sides of this equation are simplified, but we have the variable x on the left-hand side, and we have it on the right-hand side. So I'm going to use the addition property of equality to move this 2x really to the other side by subtracting 2x from each side of the equation. Now 5x minus 2x is 3x, and we have plus 2, and then 2x plus 20 minus 2x is 20. And you'll notice I've used an example here that brings us back to this particular equation here. Now, after you've done 1 and 2, you should have, if it's a linear equation, that's an equation where the variable has only a 1 as the exponent, you should have something times x plus something or minus something equals a number. Now, at that particular point, we're going to go through a method that I guess would just be called solving the equation, but I'd like to talk to you a little bit first about how we think of this. See, if you look at the expression, this is the left-hand side. If you look at the expression on the left-hand side, it's 3x plus 2. Now, if you ask yourself, if I knew what x was, what would I do to that number to find the value of that expression? Well, first, you would multiply whatever number x was by 3, and then secondly, yeah, I can spell sometimes. Secondly, you would add 2 to that answer. So if we put 6 in there, you would multiply 6 by 3 and get 18. And then you would take the 18 and add 2, and you would get 20. If you had 10, you'd multiply the 10 by 3 and get 30, and then add 2 and get 32. But the expression says, first multiply by 3, then add 2. Now what we want is we want x, in a solution, we want to end up with x equals and everything else on the other side. So what we really want to do is we want to peel away these things that are numbers. We want to peel away the times 3, and we want to peel away, if you will, the plus 2, using the addition and multiplication properties of equality. Now, what we have to do is we have to undo what was done to x. X is being multiplied by 3, and then we're adding 2. Now, let me give you an example that just may seem off the wall, but let's just spend a moment on this one. If in the morning you wake up and your feet are completely unclothed, you get out of bed and you decide to clothe your feet. First, now let's just put a little line here. First, you will put on your socks. Then you will put on your shoes. So it's a two-step process of clothing your feet, if you will. Put on socks, put on shoes. Now, When you come home at night and it's time to go to bed and you want to unclothe your feet, I kind of assume that none of you sleep with your sneakers in bed. Anyway, you want to undo what you did in the morning. Now, the opposite of putting on socks is taking off socks. The opposite of putting on shoes is taking off shoes. So, before you get into bed, what you will do is you will take off your socks, and then you'll take off your shoes, right? Wait a minute. I don't think that's even possible. I know every once in a while a student will say, look, Mr. McFarland, I can do it. But basically, that's not what you would do, right? What you would really do is, first of all, you would take off your shoes, and then you would take off your socks. But putting on your shoes was the second thing you did. Why is that the first thing you undo? Well, the answer is a general principle that when you want to undo a series of steps, you undo each step, but you also have to reverse the order. So in other words, if order of operation says 2x, we multiply by 3, then we add 2. To undo that, first we'll undo the add 2 by subtracting 2. And then we will divide by 3 to undo the multiply 3. Now, if we've got an equation, we will use the addition property of equality and the multiplication property of equality to keep both sides of the equation in balance. So if we're trying to solve 3x plus 2 equals 20, we have x on the left-hand side, so that's the side we want to peel away everything and just get x. We will first subtract 2 from each side of the equation because that's the last thing that was done to x. So 3x plus 2 minus 2 and 20 minus 2. So we get 3x on the left-hand side and we get 18 on the right-hand side. Now we will divide by 3 to get rid of the times 3. We'll do that to both sides, the multiplicative property of equality, and we end up with x equals 6. Now, one more thing, they probably will ask you to check your equation. Now, to check your equation, we're going to have a left-hand side and we're going to have a right-hand side. And what we do is we take the original equation. It's very important to take the original equation, which in this case was 5x plus 2 equals 20x plus 20. So on the left-hand side, we have 5, and we're going to put 6 in for x because we're checking to see if 6 works, plus 2. And then on the right-hand side, we put 2 times 6 plus 20. Now, what we want is for these two quantities to be equal. 5 times 6 is 30, plus 2 gives us 32. And 2 times 6 is 12, plus 20 gives us 32. So that checks, and 6 is the solution to the equation. And we're done.